and welcome back to Elementary Algebra. I am your instructor, Amy Fuchsteiner, and today we are going to be going over section 4.4 in Systems of Equations. This is the section with word problems. So, this one could be a long one. I am going to suggest that you go ahead and get yourself a snack. Get yourself some chips or broccoli or cheese and crackers or whatever it is you need, and a little bit of something to drink, a tall glass of water, a hot cocoa, iced tea. I don't know what time of year it is when you're watching this. I've got my coffee handy, so if you see me drinking my coffee, that's what I'm up to. All right. There are 6 different types of problems in this word problem section that we are going to be looking at. They include geometric problems, breaking point problems, simple interest or interest problems, uniform motion problems, and mixture problems. The other one is just 2 unknowns. I sometimes call them total. Those are the ones we're going to be dealing with first. So our skills that we're working on today are the ability to translate the word problem into equations themselves, and then to solve that system equation using mostly either elimination or substitution today. So we're going to be using both elimination and substitution, which means we're going to be looking at the problems to analyze which one we think is best. Now, as I go through these problems, I'm going to do the one that I think is best. That may not be the method you think is best. And given that each word problem is slightly different, when you're doing the actual word problems in the homework assignment yourself, you will get to choose whether you believe elimination or substitution is the best way to go with each individual problem. All right? Okay, so beginning with, we're going to solve problems using 2 unknowns. These first 2 problems are about totals and adding 2 unknown identities together to get a total. So here we go. The team photography offers 2 packages on their uniform pictures. The first package will include a team photo and 8 wallets for $29. The second package will offer a team photo and 1 wallet for $35.50. Find the cost of the team photo and that of a wallet photo. Sorry, I couldn't talk there for a minute. All right, notice we don't have the equations. We are going to need to write the equations ourselves. We're going to get those transformations or those translations from within the problem. The first package includes a team photo, so that's 1 team photo and 8 wallets for $29. So the cost here is $29. And that $29 consists of or is equal to 1 team photo and added to 8 wallets. So 29 is equal to 1 team photo and 8 wallets. This is my first equation. I have used T for the team photo and W for the wallets. The second package will come from the second equation or the second sentence. The second package offers 2 team photos and 1 wallet for $35.50. So the way I have set this up, my cost of $35.50 is going to be equal to 2 team photos and just 1 wallet. I know that kind of looks like a 7. We'll put a 1 there. Okay. This gives me 2 equations to work with. And so now I'm going to solve these using either elimination or possibly substitution. So I'm going to eliminate the ones. I'm going to move this around a little bit. I'm going to move this to T plus 8W has to equal 29. And 2T plus W has to equal $35.50. All right. What are we going to do? Do you want to do elimination or do you want to do substitution? If we were like actually in a physical classroom, I would actually do what you guys recommended. Like I would be polling the class and I would say, which one would you like? Now I just got to like mix it up enough. Okay. So I'm going to go ahead and use elimination. And to use elimination, I'm going to multiply the top equation by a -2. That's going to give me a -2t minus 16w is going to be equal to a -58. I'm going to add that to 2t plus w is equal to 3550. Right? I rewrite the equations all the time. You may not. Notice how the t's are set up to be eliminated. They are set up to cancel out. So they will cancel out from each other. And I will have a -15w is equal to, calculator. Hi, got close there for a second. -58 plus 3550 is going to be a -22.5, which I then want to divide by -15 to get that w is 1.5. If w is 1.5, no, we'll do pink. That's fine. Yeah. Since w is 1.5, I'm going to put that 1.5 into either the first or the second equation. I'm going to do the first equation. So as it's written, 29 is equal to t plus 8 wallets, or 8 times that 1.5. So 1.5 times 8. So 29 is equal to t plus 12. Subtracting 12 from both sides, I get that 17 is my t. All right. Find the cost of a team full. Okay, so T was the team. Just as a reminder, W was the wallet photo. W was the wallet photo. I keep trying to say folder. Folder. All right, so my team photo, I got 17. Find the cost of a team photo. What am I doing with the folder? Team photo and the wallet photo. So for the T, I did team folder. That's going to be $17. And the wallet photo is 1.5. That's going to be $1.50. Yes, I've got it. Okay, that would be my answer. $17 for a team photo and $1.50 for a wallet photo. And my light is just, hopefully nobody, hope it's not too much of a seizure-inducing situation here. I'll turn it off for a while, but it will get awfully dark. All right. Second problem. A carpenter wants to cut a 25-foot pipe into 2 pieces. 25-foot pipe into 2 pieces. This is a little bit, but since we have a 25-foot pipe, there it is. I'm going to draw it. We're going to cut it into 2 pieces. And I'm going to show it getting cut right there. That's my scissors, by the way. Okay, so there's where I'm going to cut it. I don't know the first part or the second part. But I know that these two have to add up to be 25. Now, there's nothing saying that that's exactly in the middle. That's why I purposefully pulled it over to one side. So this first equation, this first sentence will represent an equation that says x plus y is equal to 25. Those two pieces, this first piece and this second piece, have to add up to be 25. The longer piece, is 4 feet longer. So that is an equal 4 feet longer. That's 4. Longer is plus twice the shorter piece. Now, in my diagram, I made the shorter piece y. So this is going to be a y because that's my shorter piece. The longer piece is x. So this gives me a second equation of x is equal to 4 plus 2y. All right. So now when I look at this system, I have x plus y is equal to 25, and x is equal to 4y, just a 4, plus 2y. I added that little bit on. Okay, with these two equations now, I need to determine if I want to use elimination or substitution to solve this system. I'm going to tell you this is solved for x already. It's already solved for x. Since it is already solved for x, I'm going to go ahead and use substitution. And I'm going to put what's in this box in for the x. So that's going to give me 4 plus 2y in for that x plus another y is equal to 25. So I will now have 4 plus 3y is equal to 25. 3y is 21, and y is equal to 7. If y is equal to 7, then x is equal to 4 plus 2 times that 7. And x would be 4 plus 14, so my x value would be 18. Okay, that means that my y value here is 7. We just found that. And my x value is 18. I was supposed to find the length of each piece. So y is the shorter, and that's going to be 7 feet. And x was my longer, and that's going to be 18 feet. I can check this real quick too, because 7 feet plus 18 feet is indeed 25. And so I know I have the correct answers there. All right, beautiful. There's 2 examples, solving with some general unknowns. Now, we are going to next do some geometry problems. So here are some systems of equations that work with some of the geometry problems and formulas that you should have some knowledge of, okay? My intention is not to give you anything that requires formulas that need memorization, short of maybe some common perimeter and area formulas. All right. In 1917, Flagg created the classic I Want You poster to help with recruiting for World War I. The perimeter of the poster is 114 inches. Its length is 9 inches less than twice the width. Determine the dimensions of the poster. What is its area? 2 questions. Okay, so the idea here is that you have a poster, and that poster will be some rectangle. And the perimeter of that poster is 114 inches. Okay, the length, if I go this way, well, I don't know length and width. It really shouldn't matter. So we'll do length here and width here. All right, we know that the perimeter of 114 should be 2 lengths plus 2 widths. That is the perimeter formula for any rectangle, 2 lengths plus 2 widths. We also know Where did I get that from? This first sentence. Perimeter is 114. So 114 is 2 L's plus 2 W's. The length is 9 inches less than twice the width. So I also know that this length is the same as 9 inches less, so that's a minus 9, than twice the width, 2 W's. So this actually gives me a second equation. I know that the length is 2W minus 9. Okay. Looking at these two equations, I do notice that the second equation is already solved for L. It's already there and it's known. So I'm just going to put that in using substitution. So that's going to give me 114 is equal to 2 times the value of L, whatever's in that box, plus 2W. So that's going to be 2W minus 9 is what's going to go in there. All right. Notice that eliminates my L's. My L's are gone. And I have 4W minus 18 plus 2W. Cleaning up that right side a little bit, 114 is 6W minus 18. Now to solve this for W, we're going to add 18 to both sides. And divide both sides by 6. That gives me W is equal to 22. Once I know what the width is, I know the length is 2 W's minus 9. Since my W was indeed 22, that's going to give me a length of 44 minus 9, which is going to be 35. Okay. Now, I should be able to check at least 2 L's would be 70, 2 W's would be 44. 70 plus 44 is 114. So I can do a quick check on that. Okay, so what do I have? I have that the length would be 35 inches. The width would be 22 inches. I know it's inches because it was 114 inches there. So I have determined the dimensions, but it also asked for the area. The area would be the length times the width, or 770 inches squared. Always make sure you're answering all the questions they give you, because right, sometimes they ask an additional question and it's like, ugh, I'm going to miss that one. Okay. All right, a second example from geometry. Complementary angles are two angles that add up to 90 degrees. Oh, a good geometry question. So complementary angles are two angles that add up to be a right angle. There is generally a smaller angle and a larger angle. Right angle is 90 degrees and gets the right angle box. The larger angle is 18 degrees less than 3 times the smaller angle. Determine the measure of each. Okay. So I know that these two angles, let's call them X and Y, have to add up to be 90. That gives me my first equation. X plus Y is going to equal 90. Two angles that add to 90 degrees. That's where I got that piece of information. The larger angle, based on my quick drawing here, that's the X. This larger angle is 18 degrees less than, that's a minus 18, 3 times the smaller angle. So that's going to be 3 times the smaller angle of y. So this is telling me that that larger angle, which is x, is 18 degrees less than 3y. So x is 3y minus 18. 18 degrees less than 3y. Okay. I've used each one of the sentences in the word problem to assist me in setting up an equation. And then I'm going to look at these two. X plus y is equal to 90. X is equal to 3y minus 18. I could solve this system using either elimination or substitution, but because this x is clearly solved for again, I'm going to go ahead and use substitution. I'm going to put all of this that's in the yellow box in for the x in the other equation. Okay, so all of this that was in the x plus the y has to equal 90. So that's going to be my 3y minus 18. That's what's going to go in there. So I'm going to have 3y minus 18 plus a y equals 90. Cleaning that up on the left-hand side? Left-hand side. 4y minus 18 is 90. Adding 18, 4y is 108. Dividing both sides by 4. I'm going to get that y is 27. Since I now know that the value of y is 27, I can put that into x plus 27 is equal to 90. So subtracting 27 from both sides, I get that x is 63. So the question was to determine the measure of each angle. So x, which was the larger angle, is 63 degrees. Y, which was the smaller angle, is 27 degrees. Okay, if I do 3 times 27 and I subtract 18, I do get 63, so that worked. And 63 plus the 27, if I add them together, I'm supposed to get 90, and I did. That worked. Okay. Couple of geometry problems. What comes after geometry? Couple of geometry problems. Oh, breakpoint problems. Okay. I love breakpoint problems. Who am I kidding? I'm a math teacher. I like most of these. All right. So the idea of a breakpoint problem is that you might have two different plans. And the breakpoint is when those plans involve the same amount of money. So oftentimes, like if you join a gym, they might say it's only $5 to join the gym, but then they'll charge you $65 a month to stay at the gym, right? Whereas another gym might have an upfront fee of $60, but then it only takes $5 a month out of your account. So if you pay the fee up front, it can be cheaper by the month, or it's a quick sign-up fee, but it's more expensive by the month. And what we're going to try and do is find the point at which they're equal. And then from there, we can tell which one is cheaper when. Okay? All right. So here we have, this is the same idea, but with a copy machine. So a copy machine costs $100 with a per copy cost. So it's $100 up front and a per copy cost of 13 cents. Okay. How do I write that in? And I believe that we are stuck. We are stuck. Hold on, I don't know if I can do this. So we're going to see what happens, okay? Yay, blank screen. Okay, image. Nope, this one. I love when I have technical difficulties. Okay, we're good. We're back. All right. I hope you were able to take a break there. Would have been a good time to take a break. I should have had you take a break. Okay, personal copy machine costs $100 with a per copy cost of 13 cents. Let me help you break this down a little bit. That means that when you go to Best Buy to buy the copy machine, it's going to cost you $100. And that every copy that you make is effectively going to cost you 13 cents each. So the cost of this is going to be $100 up front. And we're going to add to that 13 cents for each piece of paper you use. I'm going to say X, or 13 cents for each copy. So right now, I'm letting the C be the cost total, and I'm letting X be the number of copies. Okay? Just want you to be aware of that. A larger or second copy machine has an upfront cost of $250, but each copy only costs $8. So my second option is that the total cost would be $250 and then 8 cents for every copy. Okay? Good? This gives me two equations, and from here, I can solve. So C is 100 plus 0.13x, and C is 250 plus 0.08x. Okay. Now, do we want to use elimination or do we want to use substitution here? Either is fine. Both have solved for C. As a matter of fact, I could even use graphing since it's technically solved for. I think I'm going to use substitution. That makes a lot of substitutions in a row. Yeah, a lot of substitutions in a row is not unusual with word problems. And I'm going to put all of this in for this cost in the other equation. I'm trying to find the breakpoint. So I am trying to find the point when the costs are equal. So I want to know when 250 plus 8 cents a copy is going to be the same as $100 plus 13 cents a copy. It makes a little bit of sense here. This is the kind of thing that in business they have to figure out all the time. All right, so what this does, though, is it puts variables on both sides. So I need to move some variables around. I get a little insecure. I put my equal sign. I'm going to subtract that 0.08x from both sides of my equation. And that's going to give me 250 is equal to 100 plus 0.05x. Now I'm going to subtract 100. So I'll have 150 is 0.05x. And I'm going to divide 150 by 5 cents. And I get 3,000 is x. So what is this telling us? This is telling us that cost, that x is equal to 300, is that 300 or 3,000, can't see, 3,000 copies is the break-even point. Once you hit 3,000 copies, then the more expensive copier actually becomes cheaper in the long run. Because at 3,000 copies, you're paying the same amount of money for both copiers. You've invested the same amount into both copiers. So from that point on, 3,000 and over, you're only paying 8 cents a copy. Whereas in the cheaper upfront, you would have been paying 13 cents a copy. So if you're going to go through 3,000 copies, you are better off paying the $2.50 upfront and then only 8 cents a copy. But if your number of copies in any given year or time would be less than 3,000, then you're better off using the cheaper of the two. Okay. How many copies are required? That's 3,000. That's my break-even point. I'm good. I don't need to go any further. I have answered the question that they asked. Problem number 6 is about a furnace. A furnace needs to be replaced. High Star Energy Furnace will cost you $6,296 up front and will average $42 a month in expenses. A second, lower rated, high efficiency furnace costs only $4,910 up front, but it averages $60 a month in expenses. So if you have the money up front, is it better to get the one that's a cheaper $42 a month? Or is it better to get the $4,910 one, but you end up paying more, $60 a month? So your per monthly payment is more. So we want to determine the break-even point for these furnaces. How long or how many months do I need to be making, do I need to have these furnaces in order to have them break even? What's the break-even timeline? And then how much do I have invested at that point? Okay. So furnace number 1, furnace costs $6,296. So my first one will be that the cost is $6,296 upfront plus $42 a month. So here I'm using C for the total cost, and I'm using M for the number of months. Okay. All right. My next sentence, a second lower rated, also high efficiency furnace, costs $4,910 and averages $60 a month. So this would be $4,910 plus $60 a month. Okay. This gives me 2 equations. Now, $62.96 plus $42 a month. My second cost is $4,910 plus $60 a month. Okay. Notice the setup is very similar to the first one. I could take this using substitution and put it in to the second equation for the value of C. I'm going to do this a little bit differently. I'm going to multiply this entire equation by a -1. I'm going to use an elimination method here. The first equation is unchanged, 6296 plus 42m. My second equation will be a -c, is a -4910 plus a -60m. Okay, now when I add these, be careful, c minus c is a 0. 6296 minus 4910 is 1386. 42 minus 60m is a -18. Okay, I'm keeping that 0 there to hold the side, just in case somebody decides to do elimination. This 0 is a side, but I have not eliminated all my variables. Do you see how there's still an m here? Because there's still an m here, this is not one of my special cases. This is not a no solution or an infinite solution because I still have a variable, right? Just a quick note here. So now I'm going to add 18m to both sides. And I'm going to take that 1386 and divide it by 18. Whoops. 1386 divided by 18. There we go. And I'm going to get that m is equal to 77. So the breaking point for the furnace is at 77 months. At 77 months, these two should be the same. So if I take, where is it? If I take 6296 and I add that to 42 times 77, I get 9,530. That should be the same if I do 4910 times 60, plus 60 times 77. That's going to be 9,530 as well. You see how I got the same number there in both of them? That is the cost. That is the breaking point. So determine the breaking point of the furnace cost. That's 77 months. That's part A. A is the number of months, which is 77. In order to find the cost at those months, I should do 6296 plus 42 times that 77. And that's going to give me $9,530. That's my answer for the cost. This is part B. Whoops, I want my red one. That's part B. So how many months before they break even? 77. Now, 77 months would be 6-ish years. So shortly after 6 years, it won't matter which one you've used. So it might be a matter of which parts are better. It might be a matter of what kind of money you had up front. But after 6 years, you have a break-even point. And the cost of your investment at that point is $9,530. From that point on, the higher efficiency furnace is only costing you $42 a month. And so it would be the better one to go with if you think you're going to have the furnace or live in that house for at least 7 years. Okay. Do you need a stretch? I need some liquid on my throat. I need a coffee here. All right. So take a minute, do a stretch. Oh, what am I supposed to do? Oh, I know. I'm supposed to try the pen thing. You guys probably did this in middle school. I did not. Oh, yeah. Oh, yeah. I can do it. Oh, yeah. There we go. Snaps for Amy. Okay. 4, 5, and 6. Let's see what we can do. Number 4 is using systems of equations to solve interest problems. We're going to be using I equals PRT. The exception here is that our time is always going to be 1 year. So because our time is always going to be 1 year, T essentially disappears. All right. Let's see how this works. Martin will invest $14,000. Part of the money is invested at 2.3% interest. The remaining amount is invested at 1.8% interest. The annual income from the two investments is $298.50. Assuming simple interest, determine how much was invested at each rate. Okay, the system of equations is broken down into two parts. The first part is that you have two amounts that together have to equal $14,000. You have the investment. That investment of $14,000 is broken into two pieces. One at X and one at Y. This gives us our first equation. That X plus Y has to equal $14,000. In this case, $14,000, right? We know that the X investment, the first part of the money, was at 2.3%. The second part of the money, which I'm going to call Y, is at 1.8%. Once I put the two investments together, I'm going to get $298.50. This gives us our second part. The interest is determined by the principal times the rate. I don't know what the principal was in the first part, but I do know it was at 2.3%. I do not know what the amount invested was for the second part, but I do know it was at 1.8%. Principal times rate. Together, I have a total interest of $298.50. This gives me my two equations. All right, now we can use elimination or we can use substitution. I am going to suggest, well, either really. I'm going to suggest we do substitution on the first one. If we're going to do substitution, then I need to rearrange one of these equations and solve them for either x or y. So I'm going to go ahead and I'm going to choose this first equation, and I'm going to solve it for x. In order to do that, I will subtract y from both sides. So x will equal 14,000 minus y. Now I'm going to take this that's in yellow. I'll put it in a yellow box again. And I'm going to put that into the other equation for the x, just like we have been doing. I've just added, there is a small step added to the beginning where we had to solve for what x would be. But that's going to give me 0.023 x plus 0.018 y is 298.50. So this is going to be 14,000, minus y. I want my calculator. Take 0.023 times the 14,000. I'm going to get 322 minus 0.023y plus 0.018y is 298.50. I'm going to clean this up. Negative 0.023 plus 0.018. 322 minus 0.005 y is 298.50. So now I'm going to take the 298.50 and I'm going to subtract 322. And I'm going to get a negative 0.005 y is equal to a negative 23.5. So now I'm going to divide both sides by 0.005 negative. And I get y is 4,700. Now, since my y value is 4,700, I can put that in over here to find the x. So my x would be the 14,000 minus 4,700. So my x is 9,300. Okay, I've used my system of equations. What does this tell me? This tells me that x, the first part, at 2.3% interest, is $9,300 at 2.3%. And my second part, or y value at 1.8%, is 4,700. So I've got 9,300 at 2.3% and 4,700 at 1.8%. How much was invested at each rate? Beautiful. I ran out of room a little bit. It's a little squishy, but it's okay. All right. Second similar problem so that we can go through it again. College used 500,000. Oh, Lord, lots of biggies. Okay, so we got 500,000 to fund their scholarship. Some of the gift was invested at 4% interest, while the remaining was interest at 4.8. So I'm going to let this be X at 4%, and I'm going to let this be Y at 4.8%. I'm trying to be a little bit more careful about the room I use. We know that the principal amounts of X and Y have to add to be 500,000. We know that when we took the principal times interest and the principal times interest, and we added them together, the interest was $23,000. Because some of the gift was invested at 4%, remaining was at 4.8. The college had $23,000 to give out from this fund. Okay, so when I added the interest here and the interest here, I would have gotten 23,000. So that means 0.04x plus 0.048y has to be the interest of $23,000. All right, we're good. All right, rewriting, because I like to rewrite a lot. X plus y is 500,000. And 0.04x plus 0.048y is 23,000. Okay. So for the first example, I did the substitution process. For this example, I'm going to go ahead and do the elimination process. To do that, I need to use some odd numbers, but I just want to show you that it is possible. Okay? So in this, I'm going to take this top equation, and I'm going to divide it by a negative 0.04. It's not a whole number, but it is going to give me the opposite coefficient here. So that's going to give me a negative 0.04x minus a 0.04y equal to 500,000 times a negative 0.04 equal to a negative 20. Oh, there's going to be another zero there. 500,000, Amy. 1, 2, 3 times 0.04. So that I need 3 more zeros. So that's going to be 20,000. 0.04. Yep, negative 20,000. Now my second equation is a 0.04x plus a 0.048y equal to a 23,000. Okay. Now, do you see how when I add these together, the x's are going to drop out and be eliminated? And then I'm going to have 0.04 minus 0.048. And that's going to give me a negative 0.008y is equal to, and this is going to be what did I miss? I feel like I missed something because that shouldn't be a positive $3,000. Okay, hold on. I need to check some work here. That should be good. That should be good. Multiplied that 500,000. Did I miss a 0? 2, 3 times negative 0.04. Negative 20,000. Negative 0.04. Oh, this is plus. Okay. Sign error on Amy's part. Always takes a while to find. All right, now we're going to divide both sides by 0.008. to get y is $375,000. So what does this mean? This means that our x would be that 500,000 minus the y. So our x would be 125,000. Okay, determine how much was invested at each rate. So x was $125,000 at 4%. And our y value is $375,000 at 4.8%. All right. Okay, a little bit better. So you've seen this particular problem done both using substitution and using elimination, and it can be done either way. Sometimes the elimination method gets some ugly numbers, but it's not like they're all that much better in the substitution method anyway. Okay, goal 5 is uniform motion problems. These are going to be upstream, downstream problems. I really like these, but it does make a whole bunch of assumptions that may or may not make sense to you. So we are oversimplifying quite a bit in this one. If you've taken a physics course at all, you know that there are way more variables than we are even going to begin to consider here. Most of the problems in this section on uniform motion have to do with still water and currents. Now, as a bit of an overview, when you are in still water and your boat or ship or fish is moving in still water, that fish has a speed. That fish, that boat, whatever, has a speed. However, most of the time, waters have a current. When you go upstream, that current is working against you. It is slowing you down. When you go downstream, you are moving with the current, and the current is actually speeding your actual work up. So if your boat is going 10 miles in still water and there's a 2-mile current, then when you're going downstream, you're traveling at 10 plus 2 or 12 miles an hour. When you're going upstream against the current, you're going at 10 minus 2 or 8 miles an hour. We're going to use these facts to help us with these still water uniform motion problems. All right. Using systems to solve these uniform motion problems. It takes a salmon 40 minutes to swim 10,000 feet upstream and 8 minutes to swim that same distance downstream. Determine the speed of salmon in still water and the speed of the current. Keep in mind that distance is equal to rate times time. This tells us that the 10,000 feet, that's our distance, is going to be equal to some rate times the time of 40 minutes. So that's our time. And if we're swimming upstream, swimming upstream means we're going against the water. So whatever speed we are, it will be our speed in the water minus the current, because the current is working against us. Similarly, 40 minutes to swim upstream. Upstream is a minus water minus C. Okay? And it takes 8 minutes to swim that same distance downstream. Downstream is the water plus the current. And this gives us our two equations. It's worth noting that W minus C is upstream against the current. And W plus C is downstream with your current. Okay? All right, so I have two equations here. 10,000 is 40 times W minus C, and 10,000 is 8. The water speed in still water plus the current. Okay. There's a couple of things here. You can go ahead and distribute. That is not a problem. I like to actually divide. Out. So what I'm going to do is I'm going to see, using my calculator, because it doesn't cost me anything but a few clicks. I'm going to see if 10,000 is divisible by 4. And since 10,000 is divisible by 4, I know that I can divide both sides here by 4. 10,000 divided by 4 is 2,500. And that would leave on the right side W minus C. Okay? Now, similarly, is 10,000 divided by 8? Is that a nice even number? Look at that. It is. So I could also take 10,000 and divide it by 8 in the second equation, leaving me 1,250 is equal to W plus C. Remember, I can do this because as long as you do the same thing to both sides of the equation, it is a perfectly valid move. I didn't distribute. I didn't get big numbers. I actually went ahead and divided both sides because the division worked out evenly. Now, once I've done that, look at my two equations. Numbers are okay. Equal signs line up. W's line up. And look at my C's. My W minus C and my W plus C are opposites in the same spot. So I can just use elimination here. I can add these two together as they are. 3750 is 2 W's. My C values, my currents, cancel out. Elimination is a wonderful thing. So now I've got 3750, and I want to divide that by 2. And I get 1875 is W. Remember, W is the speed in still water. In this case, it's 1,875, and our units are feet per minute. So I've got my first answer. I've got the speed of the salmon in still water. Now I need to find the speed of the current. I know that the 10,000 feet is 8 times W plus C. So I could put it into that. I could do 10,000 is equal to 8 times, and I want to put in that 1875 plus C. 10,000, 1875 times 8 is 15 plus 8C, right? 1875 times 8. That seems odd. Well, yeah, I'm getting a negative 5,000 is 8C. That doesn't seem right. Let's make sure that I did these correctly. Oh, that should be 250, shouldn't it? Yep. Okay, so now I need to fix this. I'm not stopping this video. We're like an hour in, so I'm not stopping. Okay. So I added an extra 0 here. That caused an error. And because of that error, this should have been 1,500. And when I divided by 2, that should have been 750. Okay. So speed in still water is 750. When I substitute, that's going to be 750. So now, there we go. This is going to be 6,000 plus 8C. So 4,000. Aha. 4,000 is 8C. Divide that by 8, and I get 500 is C. Okay. All right. C is the speed of current. And that should be 500 feet per minute. Okay. Thank you for hanging in with me. And you can see that sometimes even the simplest mistakes, like adding another 0, can cause a big old ruckus. Now, my hope is that you kind of watched me do this and saw what I did in terms of how I found the mistake, right? Before I erased everything, I double checked some calculations and my logic, because it could be that I just made a simple mistake. I mean, I don't know about you, but the vast majority of the time, that's my problem, is I do things like I've added an extra 0, okay? So most of the time when you make an error, it's not because you didn't know what you were doing. It's you made an editing mistake. You just made an editing mistake. And they're very frustrating. I get it. But it's what we need to do here. Just hang in there. And that's why I ask you to show me work, because then I can see quickly where your error is. Because sometimes I'm less a mathematician and more of an editor. Okay. All right, let's try the second example. Moving on. Okay, it takes Crush 96 hours to ride the East Australian Current at 2,400 kilometers from the Great Barrier Reef to Sydney. If a return trip around the same route takes Crush 250 hours, determine Crush's speed in still water and the speed of the EAC, the East Australian Current. Okay, little Finding Nemo adventure here. All right, so remember that if you're going to ride the current, that means it's going to make you faster. That is the speed of the water plus the current. That's going to be your rate. If you're going to ride against the current, or downstream or upstream, that's going to be the speed in still water minus the current. Okay, again, I'm using W as the speed in still water and, C as the speed of the current. So we know that our total distance is 24,000 miles. We're using distance is equal to the rate times the time. So 24,000 miles. Oh, I just added an extra 0 again. 2,400 miles is equal to the rate. If we're going to ride the current, that's the current plus the water, times 96 hours. That same distance of 2,400 kilometers is going to be the same in the return trip. That's going to be the water minus the current, because we're going to be fighting against it, times 250 hours. All right, this gives us our two equations. I'm going to move it around because I'm more comfortable with that 96 in front, and that's fine. And 2,400 is going to equal 250 times the W minus C. Okay. I'm going to do this one the distribution way, the way that I suspect many of you would do it, and that is to distribute that 96. And to distribute that 250. And then I'm going to choose, because I want to do substitution, I'm going to choose to use the first equation and solve for the W. So that's going to give me 2400 minus 96C equals 96W. And then I'm going to divide each thing by 96 in order to isolate that W. So I'm going to get 25 minus C is equal to W. Okay, now I'm going to take all of this, because it's solved for W, and I'm going to put it into the other equation where I see the W. So now I've got 2400 is 250 times W minus 250C. So that's going to be 25 minus C. 2400 is equal to 25 times 250 minus 250C minus 250C. So 2400, 6250 minus 500C. I'm cleaning it up a little bit. Now I'm going to subtract 6250. 2400 minus 6250 is a negative 3850 is equal to a minus 500C. I got a C of 7.7, so my current is 7.7 kilometers per hour. Okay, determine Crush's speed in still water and the speed of the EAC. So the current is the EAC. That looks like it's 7.7. So then the still water should be 25 minus C. So that should be 25 minus 7.7. Or 17.3. Okay. So if those work, if the EAC is 7.7 km per hour and the speed of crush in still water is 17.3 kilometers per hour. All right, let's see. I know that W plus C should be 25. So if I do 25 times 96, I do indeed get the 24,000. So that's good. If I subtract them, W minus C, 17.3 minus 7.7, I get 9.6. And if I multiply that by 250, I get 24. Yes. Always so happy when it works out. So the East Australian current, 7.7 kilometers per hour. Crush is traveling at a speed of 17.3 kilometers per hour in still water. All right, great. One last shot. We've got mixture problems. Okay. All right. Sorry, I needed to do a little dance to loosen up my shoulders. My bum is a little bit painful. I've been sitting for quite some time. I'm sure you have too. All right, we're in our last and final stretch. These are the final two examples for today. If you have a need, just pause me. All right, hopefully you're back. So we got a couple of mixture problems. We've done some of these before. This is a slightly different way of doing them. It works out fine. Just another tool for your tool belt, if you will. A marine biologist would like to set up a 40-gallon aquarium that contains 5% salt water. She currently has 8% salt water and 3% salt water available. How many gallons of each will she need? This is going to be very much like our investment problem. She has a 40-gallon tank. She is going to need to take X amount of gallons from the 8% salt water and a different amount from the 5% salt water. Okay? 3%. When she puts those mixtures together, she needs to get 5% of the 40 gallons salt. Okay, so what does this look like? This looks like gallon or tank number 1 at 8%, we need X gallons from it. Tank number 2 at 3%, we need Y gallons from it. And we're going to have 40 gallons in the end. Right? Our X amount is the 8%, 0.08 of X, added to 0.03 of Y, has to equal our 5% of 40. This gives us two equations. X plus Y is equal to 40. And 0.08x plus 0.03y has to equal 40 times 0.05, or 2. Right? Again, you can use elimination, multiply both by 0.08 on a negative, and things will cancel out. I'm going to do the first one using substitution. So I'm going to solve for x in the first equation, giving me x is 40 minus y. I'm going to take what's here in yellow and put that in for the x in the second equation. Not back into the first equation, back into the second equation. This will give me 0.08 times whatever's in that yellow box plus 0.03y equal to 2. So this is going to be 40 minus y. All right, 0.08 times 40 is going to be 3.2 minus 0.08y plus 0.03y is equal to 2. Cleaning this up, 3.2 minus 0.05y is equal to 2. Subtract the 3.2 from both sides. I have a negative 0.05. Y is equal to a negative 1.2. Why'd I write 5? 1.2. Glad I caught that right away. I'm going to take the 1.2 and divide it by the 0.05 to get that the y value is 24. What does this tell me? This tells me that the 3% is at y gallons. And if my y is 24, I know I will need 24 gallons of the 3%. That means that x, which as you recall is 40 minus y, x would have to be 16. So I'll need 16 gallons of the 8%. Before I give this as my final answer, I want to check that these two add up to be 40, and they do. 24 plus 16, x plus y, does equal 40. And then I'm going to take 0.08 times the 16 plus 0.03 times the 24. And I want to make sure that when I do that, I get the 2 that's here. And I did. So I've checked this, and I know that it is correct. All right. All right, second mixture problem. This one is dry mixtures. A tea company creates a specialty blend in batches of 220 pounds and sells it for $66 per pound. You can tell I'm tired. This month, the blend is using a premium masala tea at a cost of $56 per pound and an Indian black tea at a cost of $72 per pound. How many pounds of each type of tea are needed? Keep in mind that this is tea, so the per pound is expensive. In reality, I believe they generally sell these in bulk by quarter pounds, but those numbers were a bit much. So I went ahead and just upped it to pounds. All right, so we know that we're going to sell 220 lbs at $66 per pound. That this mixture is made up of two parts. The first mixture is a masala tea. So I'm going to use an M for masala, and that's at 56 per pound. The second blend, I'm going to use a B for the Indian black tea, and that's going to be at $72 per pound. Okay. I know that the total pounds is 220, and that's got to be some mixture of the masala tea and the black tea. So that's my first equation. The masala tea plus the black tea has to equal 220 pounds. My second equation is about the money or the mixture itself. If I have 220 pounds at $66 a pound, that is equal to some blend of the $56 a pound masala and the $72 a pound Indian black tea. And this gives me my two equations. 220 is M plus B, and then 220 times 66, or 14,520, 20, is equal to the 56M plus the 72B. M for the masala tea and B for the black tea. Okay, so how do you want to do this one? We can use elimination or we can use substitution. We did one with substitution. I'm going to go ahead and do this one with elimination. And I'm going to multiply this side by a negative 56 and this side by a negative 56. If I multiply by a negative 56, I will be able to eliminate the m's. Right? So I'm going to do negative 56 times 220. Whoops. Get rid of that. Negative 56 times 220. It's going to be a negative 12,000, negative 12,320. It's going to equal a negative 56M minus 56B. I'm going to combine that with 14,520 equal to 56M plus 72B. Okay. Plus 14,520. This is going to give me 2,200 is equal to these guys eliminated, gone. Negative 56 plus 72 is 16B. Now, in order to solve for B, I'm going to divide 2,200 by 16. And I get that the Indian black tea should be 137.5 lbs. If that's true, then the masala, since 220 has to equal M plus the B of 137.5. 220 minus the 137.5 is 82.5. So the masala T should be 82.5 lbs. Okay. Okay, so I think I have it. How many pounds of each type of tea are needed? I think I know the Indian black tea is 137.5 and the masala tea is 82.5. Now to check that, I want to add these two together, plus 137.5, and make sure that I get the 220-pound total that I was in need of, and I did. And then I also want to check it in the second equation. I'm going to do 56 times the masala tea was 82.5, and I want to add that to 72 times the 137.5, and I want to make sure I'm getting the 14,520, or 220 times 66. And I did. Okay, so hopefully that wasn't too overwhelming. Remember, you can always go through these one type of problem at a time. You don't need to sit through the entire hour-and-a-half lecture, I say at the end. But yeah, so you should have all of them. I hope that even through a few of my faux pas and mistakes that you got something from watching me figure out what I did wrong, right? As with any of the other topics, if you have any questions, please don't hesitate to reach out to me. I am happy to answer questions and help you through things. The Math Center is also available for help if you can't get a hold of me, or if you just prefer to do homework with somebody else in the room. All right? Well, it's a virtual room, but still. All right. Y'all have a good night. Thank you so very much, and we'll see you next time.